Okay, so let's move on now to case study 4. I'd like you to pause the video, please, and read the problem statement. Okay, so what do we think the hypotheses are? Well, again, Bardo's making the loaves with the same advertised weight. So we know that the null is still going to be that the population mean is 16. But what is he concerned about here? He's concerned that he's making the loaves too heavy. Okay? And actually, I shouldn't have Bardo's customers here. It's not Bardo's customers. It's actually Bardo. So see, he suspects the loaves are too heavy. So the customers are fine, but he's starting to do inventory, and it seems that he's spending more on ingredients than he used to, right? So he suspects this is because the loaves are too heavy. And if the loaves are too heavy, of course, the population average now is going to be greater than the advertised price, the advertised weight. So here, the alternative, what he's testing to prove, is that the population mean is now greater than 16. All right. So what's the estimate in the sample size? Well, he takes a sample and he has 30 loaves. Okay, and we notice that from those 30 loaves, they have an average weight of 16.35 ounces. So this is mu hat. And it's also worth noting that sigma hat, we're going to need this later on, happens to be 1. In other words, this is the sample standard deviation, okay? So this is all the input that we're going to need when we're doing our calculations. But the question is, can we do our calculation? So again, we have to check that the central limit conditions are satisfied. There's no guarantee that they will be. Do we have a random sample? Yes, we are told that. Again, that's given in the problem statement. Is it large enough? Is the sample large enough? Well, it is. So yes, because it is greater than 30. But notice also we're working with deviations from manufacturer's claims. Okay, so also our variable is normal. Even if we had a smaller sample size, even if we had say a sample size of 20, we could still run this test. Okay. And finally, is it too large? And again, we're going to say no, because that would imply that Bardo would only make 300 loaves. That doesn't seem reasonable. So now that the central limit theorem is satisfied, now we know what estimators look like if the null hypothesis is true. So the null distribution is the distribution of the estimators if the null hypothesis is true. And so we know that it's going to look like this. And in our case, we're going to use the sample standard deviation. So for our particular problem, we're going to find that if the null hypothesis is true, sample means should come from a normal distribution with a mean of 16 and a standard deviation of 1 over the square root of 30. So what we're going to do is we're going to judge our sample statistic in this distribution. We're going to take, this is 16, not 15. So we're going to take in this distribution, we're going to take 16.35. We're going to ask how likely is it we could get this sample mean if the null hypothesis was true. How likely is percentile? And that percentile in the context of a hypothesis test we call a p-value. Okay, so let's see what we get here. So here we're running an upper tail test, right? Again, make sure you get the right tab. Okay, we have a sample size of 30. We had a sample mean of 16.35. Population mean under the null hypothesis is 16. And this is 1. And we're going to go ahead and compute the standard deviation of mu hat. So it's going to be the standard deviation of the variable divided by the square root of the sample size. Okay. So this tells us what sample means look like. Okay. Sample means in the null hypothesis is true, come from a normal distribution. They're centered at 16, and they have a standard deviation of roughly about 0.2. Okay, so we can see that our value is roughly 1.75 standard deviations above the mean. So it's going to be unlikely, but the question is how unlikely, and that's what we're going to figure out now. Okay, so remember, upper tail means I want to use 1 minus norm dist. And this is my value. This is a normal distribution's mean, normal distribution, and standard deviation. It's always true. Okay. And this is our p-value, about 2.76. So it's small, but it's not too small. But again, we have to compare it relative to alpha, right? So our alpha here is 5%. So our p-value, which is about 2.76%, is less than 5%, which is alpha. So when the p-value is less than alpha, sorry, 5% is equal to alpha, we're going to reject the null. Right? So we're ready to state our conclusion. We would say at alpha equal to 5%, we find there is sufficient evidence to conclude that the average weight of Pardo's loaves of bread is greater than 16 ounces. And there we go.